Hello and welcome back to this course on Fundamentals of Data Science. I am Professor Anand Paul, and today we are going to discuss about big data and 10 V's of big data, characteristics of big data. So what is the objective of today's course? Well, here it is. We are going to discuss about what is big data and 10 V's of big data, various characteristics of big data. You'll be surprised to see the 10 V's are not just 10 V's, and today we are talking about hundreds of V's. By end of discussing about those 10 V's, I will explain what are the other possible V's that we have. Well, as this course is all about fundamental of data science, let's begin with what a data science is. Okay, here it is, starting with this characteristics of big data. Talking about this data itself, we know that data sets grow rapidly to a certain extent because they are increasingly gathered by cheap and numerous information sensing Internet of Things devices, such as mobile phones, sensors, and cameras, microphones, etc. So that's why today we have enormous amount of data generated. And these days, for example, the mobile devices contains tens of sensors, which means that they do generate a lot of information continuously. The current usage of this term big data tends to refer to the use of predictive analytics, user behavior analytics, or certain other advanced data analytic methods. Well, when we talk about big data, it's not that we are talking about just the huge volume of data. There are various other characteristics of data that are there. And today's lecture, we are going to see what are the other characteristics of the big data. Here it is, starting from the traditional one, the big data, extremely large data set that may be analyzed computationally to reveal a certain pattern, a trends, and association. That's what a traditional big data definition implies. And we are aware that the big data means a lot for all the organization today, because the world is generating huge amount of data and people are trying to make good use of this data, whether it is agriculture data or whether it is environment data, if it is a data of a patients in the hospital. Yes, all these data that are gathered are there, out there, this huge amount of data. Some data are in the social media, some data are in the IoT devices, some data are just out there which has not been retrieved. Yes, we are just storing the data and then deleting the data again and again. There are some devices that does that. We'll start with the basic characteristics of the data, the 3 V's, the traditional 3 V's. The first one is the volume, then the velocity, and the variety. Well, from the word volume, we know it is huge amount of data, and from the word velocity, which means high speed data, you could say. These days data are in motion, the streaming data, like every seconds terabytes of data has been streaming online. Yes, if you consider this project called Square Kilometre Array that is located in Australia and in South Africa. They have huge antennas towards the space, and they are collecting huge amount of data every second from the space. Well, that clearly applies to the term velocity. And then we have this variety data in many forms. Some data are structured data, some data are unstructured, some data are text data, some data are multimedia data, maybe sound signal or video signal. Yes, there are different forms, and these different forms can add complexity to the data. Yes, these are the typical three ways: volume, which is a huge amount of data; velocity, the speed at which it arrives; variety at different forms that adds complexity to this big data. Well, we haven't stopped with this 3 weeks. We are already into this 10 ways. Yes, we already saw what is volume, velocity, variety. Then comes the other ways like veracity, valence, validity, vulnerability, volatility, visualization, values. And of course, we are now heading towards 100 V's. Let's briefly see what are these other 7 V's before we discuss few points about those 100 V's. Okay, there it is. We know this, the first V we already talked about, the volume, and here is a simple example of this global IP traffic from Cloud Center in 2018 is around 10.6 zettabytes, and their annual cloud data center traffic is just 3,838 exabytes. That's only for North America. And traffic from data centers to user worldwide is 1.61 zettabytes. Well, they are quite huge volumes. Yes, it's one of the characteristics of the big data, simply too big. Then comes the variety. As we have seen that it comes in many different forms. Some are numerical data, some are audio data, some are just time series data, multidimensional data, and some data including the text message we receive, the emails that we receive, the photos, images. These are all the variety of data that we have. At times a single application can be collecting many different types of data. And to extract knowledge, all these types of data had to be linked together sometimes. You have a message, text message, then you have an image, for example. Along with that you have a voice note or a sound signal. Unless you could have analyze all these different variety of data, you will never extract, or in other words, you will never extract the needed information. Yes, big data analytics includes this complexity, and we have to overcome this complexity by various techniques. Yes, we talked about the velocity, that is the speed. A data is being generated fast and need to be processed very fast. Yeah, as I mentioned, I'll mention an example of this square kilometre array. It's just one example. There are other examples as well where you can talk about high speed data. At times at high speed data, there are a lot of challenges comes in, like, are you going to skip some data? Are you going to filter filter those data? So what is our objective? What are we going to do? Because we cannot really analyze all the data at that real-time speed. We may have to filter it out. So we will discuss few points on that later on in our course on how to handle such high-speed data. So here is some of the examples like e-promotion, healthcare monitoring. They are some of the challenges, right? Especially when it comes to healthcare monitoring. You have to respond to any emergencies very quickly, especially an accident or someone in a nursing home needs a help. Yeah, we need measures to be taken, decisions to be taken quickly. Then comes the veracity. In other words, data in doubt. There are certain uncertainty due to the data inconsistency or incompleteness or ambiguities, latencies or deceptions. So how certain is your data? Is it reliable? Is it predictable? So does it have any abnormality in the data? How do we know that? So that's the question of veracity. When you have data, you are a little bit doubtful. Is this data really the true information? Is it well authenticated? Does this data has consistency? Is it complete or just few information you have and the remaining information is missing? What is the ambiguity of this data? Well, in many data sets, we have these questions arised. You don't know what the data is, or you're not sure what the data means, like why this data is here. You're not very sure. In other words, you don't have any idea about what is happening with this data. Well, that happens at times. Then comes the valence. So this valence refers to the connectedness of big data in the form of graph, just like the atoms. You know, like atoms are connected together and the valence electrons are just surrounding the nucleus, just in the outside part. Just like that, they are kind of connected. A data item is often directly connected to another data item. Just like two Facebook users are connected by some means. In other words, two employers are connected in their workplace. You can even think about two students, they are connected somehow. Yes, sometimes data could also be indirectly connected. Say for example, a student in your school might be connected indirectly to a student in another school in another country. Of course, you both have certain similarities. For example, you both are in the same major, you both are in the same year, you both are learning the same subjects, and there may be more other similarity that makes you connected somehow. For example, just like two scientists are connected because they are both physicists. A city is connected to the country it belongs to. Yes, we can always come up with certain relationship connections between each data that you have. Then comes the validity of the data. A validity in data collection means that your finding truly represents the phenomena you are claiming to measure. Yes, can you validate the data? It's one of the important part. It's not about just having the data. Can you really validate? Yes, validate refers to how accurate and correct the data is. Apart from the consistency, the data quality is what questioned here. The quality of the data should be validated. Or can we have a means to evaluate and validate this data? That's one of the questions to be considered. Then comes the vulnerability. Yeah, security issues in big data is one of the prime concern. We don't have much algorithms and tools to protect the big data. So that's why in the last decade many researchers are focusing on security issues in big data, especially with respect to privacy. You might have also heard about the new privacy rules that have been set up by European Union last year. And moreover, many other companies including Facebook, Apple, Amazon, all big companies, even Sony, have been hacked, and some of their users' information has been passed on to various people. Yes, that's where the vulnerability comes in. So it is in most cases are open to vulnerability. In other words, almost all the data that are generated today are somewhere in the cloud, and we know that cloud is not 100% secure, which means that all the data are open for this attack. So this is a serious question, and many people are working hard to make some hard algorithms so that they can secure their system. Volatility. So in big data, the volatility refers to how long a data is valid and how long it should be stored. So volatile, like when you have data, does this have an expiry date? Can I save this data for like 5 years, 10 years, 20 years, 30 years? How long I should have this data, or how long this data is valid? Do I have to store this data for that long? And we know that there is other difficulties of storing the data. Yes, of course, the storage medium, the hardware itself, at times have certain issues, so it gets somehow physically certain issues that lets maybe it's completely corrupted or somehow it has been damaged. It has been happening in many data centers around the world. That's why most of these data are always having a backup in other areas. Yes, that's another question to be answered. Then comes the visualization of data. Yeah, well, these days we have many tools that can help us to visualize the data, and visualizing data really can help us to understand how the data looks like. Just by looking at the data, you can sometimes clearly see the pattern in which it flows, and with this pattern you can also analyze what is the actual movement of data, or what is the actual things that are happening with the data. Some of the data are outliers, some of the data are concentrated at certain region. If it is a time series data, then you can clearly see what is happening in a particular time. Yes, you can visualize, and these days we have many tools to help us to visualize this big data. And finally, we have this value. Well, whatever we do with the data, in the end we want to make sure that we extract some values. So what are these values we talk about? Well, let's consider an example. A certain airline company, they started to use big data analytics for almost all their parts. So they collect the data that is generated in various sensors and actuators in the aircraft, and based on those data they try to analyze how a maintenance should be given to certain parts, and accordingly they managed and maintained those spare parts or different sections of the aircraft, and at times they also replace some of the parts with other parts, by which eventually they saved a huge amount, millions of dollars they saved by end of the year. So what do we learn? We come to know that they have generated a value out of this data that they have. Yes, this is just one of the example. Maybe another value you can think about is, like, for example, you have your data about your health, your heart rate, your activities, your sleeping activities, your exercise activities, your steps, various other health data are there, and this data can really help you to see what is your pattern of life. And if you do have some problems, and if your doctor is looking at all your health data, he can give us some good suggestions, or he can actually give us a better treatment. In other words, the value we are creating here is about your health. Yes, there are various different ways in which we can create the values. Well, we have seen this 10 V's, and apart from this 10 V's, there are still a lot of other V's that are available. For example, let's talk about one V here. We talked about veracity, velocity, volume, and values. Let's talk about certain V's. We have vagueness. It's one of the V's. Here is like meaning of this vagueness. As you can see, it's like a fuzzy thing, right? Sometimes your data are not very clear. So sometimes your data are available, and when you look at the data, it's kind of fuzzy. You do have, sometimes you do have only half the data that are supposed to be there. You should be having the full data, but you are only having the half the data, and these data are not clearly giving you what you need. That's where the vagueness comes in. And apart from vagueness, we can also talk about other issues like vastness. Is another V. Well, as you can see, the word vastness, when it comes to the big data analytics, we have lots of IoT devices, and they of course generate huge amount of data, and we can also call that term as bigness. As big data, we call bigness, and this bigness is generating the data that creates this vastness. And this data that we are generating from various devices are accelerating at a high speed as well. So in combination with velocity and the volume, this vastness is heading forward in a direction of complexity that we have in hand. Okay, there are many more other similar V's that are available. As I told you that there are hundreds of V's that we have these days. To talk about few more V's, one is called visibility. Visibility, the data science, basically we want to check whether these data are clearly visible to us. When I say visible, it's not about visualizing the data, whereas at times data are quite complex in nature, and we may not be able to view certain contents clearly. It's not about vagueness, it's about data are there, but you are not able to see what you need. Like you cannot able to extract the information. Maybe you have to filter out the data, and then later on you may have to analyze the data. So that's about the vagueness. The other one is called vogue. So we have this machine learning, and then the machine learning becomes an AI, and then you have this AI becoming to another term. So one thing is becoming another. You have a statistical data, and then you use the statistical data that becomes a machine learning data. Later on, the machine learning data is becoming an AI data, and one thing is shifting to another thing. So this process is kind of work for us. So likewise, there are a lot of other ways. For example, we also have voyage. So voyage is like we are keep on learning about the data, and we are keep on trying to tackle a problem. When we tackle the problem, we have streaming data comes in, and when the new data comes in, you can solve the problem in a new direction. In other words, you are always keep on updating information based on the data that you have in hand, and accordingly you make decisions. So these are some of the other ways. I am not going to talk about all those hundreds of ways. You can check by yourself. There are lots of other ways that are part of characteristics of the big data. So what we saw? Yes, we were talking about characteristics of big data, and that includes not only basic 3 V's or 10 V's of big data, rather hundreds of V's. And we saw some V's in today's lecture. Yeah, these are some of the basic characteristics of big data. These are some of your references we have here. And what are we going to see in the next lecture? We are going to discuss about big data quality, some of the challenges in the big data, some information about sentiment analysis, and finally about rare event. So that's what we are going to see in the next lecture. I am looking forward to see you there. Until then, goodbye.